Hi, I'm Flavio Cavalieri. In this video, we're gonna develop a basic project to support the development of our course lectures. This project will basically connect application variables to spreadsheets, supporting several proof-of-concept tasks. As complementary material, I advise you to check out the STM32 Week website in order to understand concepts behind some STM32 products, as STM32 Cube Monitor, STM32 Cube IDE, and much more. In the Wiki website, you can find important information about some STM32 software products, as Cube IDE, Cube Monitor, Cube MX, and so on. So it's very interesting to check out this week in order to understand. In this first project, we're gonna produce a base project to connect some variables and some spreadsheets. So this will be our proof of concept for many tasks in this training. So we're gonna basically generate some connection between a Cube Monitor application in order to read some information from a spreadsheet, retrieve this information, send this information to some specific variables in our projects, process those variables using, for example, filter concepts, filter tasks, and generate output signal to some variables. These variables will be connected in the Cube Monitor project to an output generated CSV file. If you are starting to explore the STM32 Cube IDE and STM32 Cube Monitor, I advise you to subscribe in my other training, which is called Mastering STM32 Microcontrollers. So let's start our development process. We're gonna start STM32 Cube IDE, and we're gonna create a project folder in the C called Projects DSP. So I use this base directory for our projects in this course. So I'm gonna latch this, and I will be waiting for the STM32 Cube IDE open. So we're gonna make some important configuration at the very beginning. So in the moment I'm recording this training, I'm using the version of STM32 Cube IDE 1.10.1. So check it out which version you have in the exact moment that you are doing this training. So I'm using the 1.10.1 just as an important information at the very beginning. So the first thing, we're gonna start a new STM32 project. And we're gonna need now to select the desired microcontroller for your implementation. So I don't want to connect to the internet right now, and this we're gonna start the target selector for STM32 microcontroller family. Next step, in the target selection, we need to find for the commercial part number. In our case, is the microcontroller STM32 F407ZG-T6, the one we are using in our development part right now. So ZG-T6 selected. Next, and very important step, define our project name. So you're gonna use the same folder for all the projects in our training. So I'm gonna create the first project here, and I call this project as Monitor Basis. So in order to generate some application to connect the variables to the Cube Monitor, provide an interface to connect to a spreadsheet, to an input spreadsheet, and provide some output variable in this project to connect again to the Cube Monitor, and this output variable will be connected to our output spreadsheet. So the first steps for our implementation. So everything we're gonna select by default here, we're gonna next, and we're gonna finish it in the moment of this video, I'm using the firmware version 1.27.1. So you copy only necessary library files and finish it. So first of all, we need here to make some configuration, some important information to our first project. So at the very beginning here, I'm gonna connect a high-speed clock to our microcontroller in order to use the resources from the crystal, which is basically connected in the development board. So I'm gonna use here crystal, and as you already know, this will gonna physically connect the pins, the GPIO pins, the microcontroller pins, to the desired hardware. Okay, so this is the first step here at the very beginning. Now we're gonna need at the system core, systab, we need to connect some specific debugger. In my case, I'm using the ST-Link, so I need in this case now to use a serial wire connection to provide the interface between the microcontroller, the development board, and the ST-Link peripheral. So as you can see here, this automatically generate here the pinout PA13, which is our SWDIO connection, and PA14, which is the SW clock connection. So those two pins need to be connected to a proper ST-Link hardware. So I'm gonna open my camera right now, and as you can see here, those two pins, they are connected with those jumpers in the ST-Link. So as you can see here, PA40, it's connected to the SW clock line. PA13, it's connected to the SWIO, DIO, and I need to connect also the ground, the GND. So basically those three connections, they are necessary to provide a communication between the debugger, okay, the ST-Link, and the development board. So I'm using an external power supply, 5 volts power supply, to supply my development board. So I don't need to connect the 3.3 volts line of our ST-Link to the development board. Only the GND as a reference and the signal pins, clock and IO, SWDIO and SW clock. So they are very important in order to establish a connection to transfer our projects to the microcontroller. So that's it for the first moment here. Now we need to check out our clock configuration. So as you can see here, our development board uses an 8 MHz crystal oscillator. So we need to define here, in order to operate correctly, 8 MHz. We're gonna select in this internal MUX the high-speed external oscillator. So this is the correct path now in order to reach the desired speed of our microcontroller. I'm gonna set the maximum possible speed for the H clock line. So I'm gonna use 168 MHz. I'm gonna press enter, and as you can see here, this we're gonna provide the necessary configurations for that. So look at that, very important. He automatically changed the first MUX to an internal oscillator, but I don't want to use in my project an internal oscillator. I have an external crystal connected to the desired microcontroller lines, pins. So I'm gonna use the high-speed external. I'm gonna select this path here. So I have here some prescalers. This is connected to this system clock MUX, and the system clock MUX will take this path till reach the H clock, the high clock, which is basically 168 MHz. So this is gonna generate automatically the solution for our prescaler information. So far so good. Now we have the maximum 168 megahertz clock frequency for some buses, some internal buses of our microcontroller, like the APB2, okay, and other ones. So this is very important and necessary at the first time for each project we're gonna generate in this training. So I'm gonna save it and I'm gonna generate the code. All right, so the code was generated. As you can see here, we are using some blank theme for our development environment in the Cube ID. So I'm gonna change the preference and I'm gonna change some fonts size here and also some theme properties to be more visible, to be more adequate for the training and also for my user, because I like to work with bigger fonts and I like to work with another kind of theme for my development interface. So to change this, you need to go here in window preferences, and under window preference you can check it and you can select it here, the information needs under general appearance. So I'm gonna use here the dark theme. This is the first configuration I'm gonna made it. So I'm gonna apply. So as you can see here, it just changed my background theme. I don't want to restart this. Okay, and second and very important, I'm gonna change also my colors and fonts. And I'm gonna select the here C editor, and under editor tab I need now to edit and found the preferences for me. So I'm gonna use the default, the standard font, okay, and I'm gonna use here 12 for the size. So this will be better to present in these training sections, in those videos. So I'm gonna select here, okay, I'm gonna put apply and close. So that's it. The project is created. So if you need some more information relating to the Cube ID, you can check it out my other videos and subscribe in my Mastering STM32 microcontrollers training. So I'm gonna open here the main.c and I'm gonna generate some basic code, some basic projects in order to operate it, to connect some project variables to the Cube monitor, some input variables to receive information from a spreadsheet, from an input spreadsheet, process those variables, generate some output variables, and connect these variables to the Cube monitor to generate an output spreadsheet. So let's start coding. First of all, I'm gonna include a very important library I use a lot called string.8 in order to manipulate string variables. So here now at the user begin, you're gonna create the variables. So we have defined spaces here where you can create your user's process variable. So here I'm gonna define the variables I wanna use in my project. So I'm gonna basically create an assigned integer 16-bit for this project called sample input as an input variable 16-bit assigned, a sample output variable, and a sample old variable. So I'm gonna explain this through the course of this video. So I'm gonna create here a float data point, a float process variable called data input, okay, to work with floating variables. I'm gonna create another one, assigned integer 8 bits called state to my state machine. So I'm gonna create a basic state machine for this project and the other projects too. I'm gonna create another unsigned integer. Okay, you don't need it. You can basically define here in the sequence. I'm gonna call a string data. So this is also another interesting variable I'm gonna explain later on. I'm gonna declare other float variables here. So as you can see here, this basically create in some memory address the data in as float 4-byte variable. After this address, this will declare two 8-bit variables in the next address, and in the next address we created another 4-byte variable called data out for that output, and then you're gonna create an array to work to manipulate my data. So I'm gonna create an array called data input array, and this array I'm gonna define with 1030 bytes, 1030 times 4 bytes, 1030 positions for my float variable. Okay, this has one meaning. I'm gonna use 1024 samples for providing my filters, okay, solution. So if I use 1030, it's more than 1024. So I still have enough space to save while 1024 samples for my data array. So I'm gonna use 1030, and I'm gonna create a data output array with the same size, 1030. Before leaving the variable declaration here, I'm gonna change this particular mistake I committed. If you see here, I declared a semicolon. I inserted a semicolon just after the first float variable here in the line 48, the data out variable. So for the compiler, when it compiles, this will change automatically the data input array and data output array, the next variables, to an integer type, and we don't want this. So I'm gonna change the semicolon to a comma instead, and now all those three variables are declared as float type. So moving forward, next we're gonna change our program inside the int main void. So let's now make our changes here in the int main void. So I'm gonna skip this information, as you can see here, and under the user code begin, I'm gonna implement the initialization for my variables. So I'm gonna basically declare sample old with 0. I'm gonna start with 0. Sample in, gonna start with 0. Sample out, sample out, same. Okay, no, sample out, let's gonna start with the position number 1. I'm gonna explain later on. Data input as float, I'm gonna start with 0. Data output, also float, I'm gonna start with 0. Trigger data, gonna start also with 0. Okay, so now I'm gonna set all my data input array with a 0 value and all my data output array also with 0 value. To do that, I'm gonna use the manset function, and I'm gonna pass the necessary parameters for that. The first one is the data input array. The second one is the decided value. And the third one is the size I'm gonna set with value 0 in my array. So I'm gonna basically call it the function sizeOf to calculate the size of the data input array variable. So this basically clears all my data input array. Same thing for the data output array. So memory set data output array 0 size of data output array. So far so good. All right, moving forward now, in the user code begin area inside my while loop, I'm gonna create now my switch case statement, my state machine. So basically switch state variable. In the first stage, which is the stage number 0, I'm gonna copy each sample to the input array. As you're gonna see in the next steps, we're gonna connect a data input float variable to some important task in the cube monitor in order to read the values from a spreadsheet. So each value we capture in the spreadsheet will be connected to this data input variable. So we need to provide some solution to retrieve the value from the spreadsheet. So each row we're gonna save this value in a data input variable, and we need to take this value from the data input variable and save this value in a specific position of our data input array in order to copy each sample from the spreadsheet. So far so good. So this is the state number 0, so case 0. All right, in the case 0, we're gonna check if let's make some indentation here. If sample in, okay, my sample input counter is different from the sample old, so this it means we increase our sample in counter. So when our sample in counter is different from the previous value, it means that we need to save a newer value from the data in variable to the data input array. So we retrieve a newer value from our cube monitor, as I'm gonna explain later on. So this we're gonna basically copy to the data input array. We need now to specify the position of our array, and for that I'm gonna use basically the counter sample input minus 1. So sample input minus 1. So it will be very important to define the sample input correctly in our spreadsheet, in our generated spreadsheet. So I'm gonna explain you later on how to generate this spreadsheet. Okay, so this will be receiving the information from the data input variable. Okay, data input variable. So each sample we retrieve the value. You're gonna take the value from the data input, which is connected to the cube monitor, and it's basically connected to some row, okay, in our spreadsheet. So row by row, we're gonna read from the spreadsheet, get this information, save this information in the data input variable, and doing this case statement, this state machine, we're gonna provide the necessary functionality to read each sample and correctly connect the value from each sample to the data input array position, correct position. And at the very end, after saving this value, we're gonna basically increment the sample old. Okay, So this is gonna basically increment the sample odds. So the sample win, for example, it's counting and is basically now in the number 10, for example, and the sample odd is number 9. So it means we have a difference. So if you have a difference, it means we receive a newer value in the data input variable. So you're gonna save this value in the proper data input array, and we're gonna increase the sample odd. So next time you come here, if the sample win still the same counting 10, so it means this if statement is not true, and we're gonna not enter here till we get a newer sample. That's it. All right, so next here we're gonna check if sample odd reaches 1026 samples. So it means we save 1000, at least 1025 values starting with 0. Okay, so if that's fine. So if this condition is true, we need again to reset the value from the sample odd variable, clear this value. We're gonna create it, okay, initialize the sample out counter with 1. As you can see here in the initialization, we initialized the sample out with value 1. So we're gonna not start our output spreadsheet with 0 as a reference for the position of our vector, our array. So we're going to start with 1 to make a differentiation. So when you have value 1, it means we get a newer value to save in our output spreadsheet. So we're going to use this, and needs to move to the state number 1. Okay, so it's very necessary to call at this point the break at the end of each case in our switch statement. Okay, so that's fine. The next state, in the next state, we're gonna copy data input array to the data output array. So this is basically simple right now because we are not doing any filter or something like that. We are just at this point, we already get all necessary information from the input spreadsheet. So each row, okay, each line from our spreadsheet generates one value. Each value we connect the proper position of our data input vector, our data input array. At the very end, after getting all the information and save this information in the data input array, we move to the next stage. In this stage, I'm gonna save all information from the data input array to the data output array. I'm just making a copy from the data input array to the data output array. Okay, this is just to give you some necessary information to implement a proof of concept project. In the next projects, we're gonna basically change this state number 1 in order to fit to our application requirements, like a FIR filter, finite impulse response filter, or infinite impulse filter, IIR, and so on. Okay, so this is the case number 1. And in the case number 1, we're gonna call a memory copy function in order to copy the data input to the data output array. So data input array, size of data input array. So far so good, and this is gonna move automatically to the state number 2. And don't forget, we need the break at the very end of each state. That's it. Okay, so you're gonna next state, implement next states. The next state will basically save each output array position to the data output array variable. So to do that, we need basically to save this value from time to time. So you're gonna need to we need to define a proper sampling time for that. So this is something very important, because remember, we're gonna save this value in a data output variable. This data output variable will be connected to the cube monitor by the ST-Link peripheral. So this is a very fast connection. But the cube monitor, we need to save each sample to an output spreadsheet. And this is not so fast as we can imagine. So to generate this CSV file and save this new information, we're gonna need to respect some delay. We're gonna need to respect some process time from our machines, our computers. So in order to fit these requirements, you need to find a proper delay between each newer data output value. Otherwise, you can get serious problems when you are saving your spreadsheet, and you're gonna not save with the correct values, with the correct samples. So this is very important. So I'm gonna just comment here. So with some proper sampling time, copy each output array sample to data output variable. So this is the best explanation. Okay, this is the best explanation, the best comment for this state. So I call it here case 2, state number 2. So what we're gonna do basically here, we're gonna take each output array value and connect each value, each sample, to the data output variable. So that output variable will receive the data output array, and we're gonna call here, we're gonna pass here the sample output minus 1. Remember that the sample output, after we skip from the first state, we initializate this with 1. So 1 minus 1, it's 0. So you're gonna starting from the 0 position of our data output array, because our data input array, which is basically copied to the data output array, we have actually the 0 position for this array. Okay, so you need to connect the 0 position of this array to the 0 position of the data output array. Okay, so I'm gonna call a hold delay function. So a hold delay function, and in my case, the best value, I got it, and the reasonable value to achieve my requirements, my speed requirements to generate the output file was 25 milliseconds. In this 25 milliseconds, look at that very interesting trick I'm gonna explain later on in the cube monitor. I'm gonna generate a toggle information in the trigger data variable. So I'm gonna set as 1 for the trigger data. I'm gonna call array. This is a very interesting trick I'm gonna explain. I'm gonna call again the raw delay for the same 25 milliseconds, and I'm gonna reset my trigger data. So I toggling this variable 1 and 0. So this will be very interesting. Will create an effect in our output spreadsheet, and I'm gonna use this value in the Excel that I'm gonna explain later on in this video to retrieve the information, the correct information for each sample. Okay, I'm gonna explain later on. So in my output spreadsheet, I'm gonna basically have 3 columns. One column for the number of my position, okay, vector position, array position, one sample, basically, one with the sample actual value, okay, the sample value, the data out, and another one with the trigger data. So basically with these 25 milliseconds for trigger data as 1 and 25 milliseconds for trigger data as 0, we can skip from the trigger data 0 in the column number C of the Excel, because this is probably a not good value for our data output, and we're gonna focus on each information we have for trigger data as 1. And after that, we're gonna remove the duplicated values in the decided column. So I'm gonna explain this later on and you understand. This was a very interesting trick in order to retrieve all necessary values from my variable. So this is very important in order to not to avoid getting some trash information in our output spreadsheet. So this is very interesting and it works very fine. So sample output plus plus. So I'm gonna increment my sample output, and I'm gonna keep in this state number 2 as long as my sample output is less than 1026. So I'm gonna basically set here an if condition. If my sample output is equals 1026, so it means I got all necessary values. I send all these necessary values to the output spreadsheet, and that's it. So my sample output equals 1, and I don't want to come back to the state number 0 and repeat my process. So I'm gonna move to a state number 3, and this state number 3, I will basically do nothing. So I will freeze my application in the state number 3. Very important. Don't forget break at the end of my state. So I'm gonna call here case state number 3 and break, just to freeze my application in this state. So my application basically copy all input variables, connect to the input spreadsheet. Each sample, each line from this spreadsheet will be copied in the data input array till I get my necessary information. Okay, so I'm gonna move to the next state, and in the next stage I will just basically copy my data input array content to my data output array, basically this. And in the state number 2, I'm gonna get each sample, retrieve each sample of my data output array, connect to the data output float variable. This data output float variable will be connected to an output spreadsheet. So I'm gonna generate an output spreadsheet with each single sample value from my data output array. All right. Next step, I'm gonna save the input file .csv, okay, to the temp folder. Okay, I need to move the input file .csv, so I'm gonna provide some files for you in the Cube Monitor Flow, okay, zip file. So in the Cube Monitor Flow zip file from my training, you can export this, and you have some information here, some files here. So just move the input file, okay, to the temp folder of your PC. So just to show you here in the Excel, the input file, what is exactly the input file? Okay, so I'm gonna move it here. In the column A, I have, it's very important here in my application, I have the sample in the column A, and I have the data in the column B. And look at that, the sample is starting with number 1. This is why in my application you saw I'm using my array, my actual value from the sample minus 1 to save in the 0 position of my array variable. Okay, so this is why I'm not starting with 0, but I'm starting with 1. So look at that. Just to give you some information, I use the first values with a float, okay, like this, positive and negative values, in order to see if our Cube Monitor implementation is working with float variables. The other ones is just basically something like 85, 850, 10 times, 86, 86, 860, and so on, till I get my all 1026 values. So 24, right, but look at that, I just save 0 value for 25 and 26 here, okay? But for me it's necessary in the next applications that I'm gonna working in with the filters to get all 1024 values and process my filters. That's it. Okay, so this is basically the input file. I'm gonna save this input file in my PC temp folder. All right, so regarding the STM32 Cube Monitor flow, I gonna send you the necessary files to implement that, to import this flow. So you need basically to come at this place here in the Cube Monitor and import. Okay, you can basically copy and paste the information here if you want, or you can select a file to import. If you're gonna select a file to import, as you can see here, I need to move to the correct folder, which is in my case Cube Monitor flow. I'm gonna send you this Cube Monitor flow as a zip file, and you need to export. You're gonna move to all files, and I have basically here a txt file. So if you wanna open the txt file, copy the txt file and paste the txt file here in this area, it's possible. It's one possibility, and the other possibility is just click in this CSV read write fluxo here and open. That's it. So this is basically all the code for the STM32 Cube Monitor already implemented. So you don't need to implement this by yourself, but you need to modify to understand. So as I said in the very beginning of this video, I advise you to read the document, to read the week about the STM32 Cube Monitor, to be used with that. And as I already mentioned before, if you want, you can subscribe to my STM32 Mastering microcontroller course, and in this course I will also explore the Cube Monitor tool. So I'm gonna import here to my current flow. Okay, I'm gonna import a copy here, and that's it. As you can see here, create.csv log file. That's a lot of things here, and I'm gonna just move a little bit to explain you, okay, what is exactly happening here. But before I will transfer my application in the Cube IDE, so what I'm gonna do here, I'm gonna basically run debug. So as you can see here, my microcontroller development board is already connected to my ST-Link. This will compile my application. Okay, check if I have some error or not, so no errors. And this will gonna basically transfer this application, this whole application, to the microcontroller itself. So I'm gonna just make here okay, the debug it's corrected, GDB server and so on. I'm gonna press OK, and let's wait for the feedback. Waiting for the debugger connection. Okay, so it's connected and transfer and download the application successfully. So I'm gonna just make a press to the switch. This will gonna open, okay, my debugger interface. And as soon as open my debugger interface, it moves to the first line here. It's saved in the microcontroller. It's already transferred to the microcontroller. I'm gonna terminate. So this is basically what I need to transfer using the debugger, okay? All right, so the correct application is installed in the microcontroller right now. Good. So coming back here to this important Cube Monitor project, as you can see here, I have my input probe and my output probe. This is connected to the ST-Link. Let's see if this is connected to the right ST-Link. So I'm gonna double click, and as you can see here, this is I have these two probes, but actually this probe, the first one here, is the one which is connected to my ST-Link peripheral. All right, so we need now to find the variables to find the correct variables, to connect the correct variables. So I'm gonna basically now double click here at my variables, and as you can see here, I'm gonna use the data input, data output, sample input, sample output, okay, and trigger data. This is another variable I'm gonna use in the next projects. Okay, data input, data output, sample input, sample output, and trigger data. But look at that. This is looking for another project, IIRbasis.elf. We didn't reach this project yet in our training, in our course. So I need to press here, okay, in this pen, and I need now to go to C projects. And remember, we created our project in C projects DSP. Okay, and the first project, if you remember, we created the first project. The first project is called Monitor Basis. So Monitor Basis. So this needs to be very corrected. So projects DSP is the correct folder. Monitor Basis is the name of our first project. Debug is the correct folder to find information. And I'm gonna press update. And look at that. So let's see if it's working. It didn't found the information. Maybe I missed something. Okay, let's click it here. Look at that. When I click it here in the file, you're gonna find automatically monitorbasis.elf. So this is the correct one. It belongs to the Monitor Basis project and is inside the debug folder of our Monitor Basis project. So I'm gonna basically press here, and it's gonna select the variables. You're gonna find the project variables. And as I already mentioned, I need the data input, okay, the data output. So basically, for this project, to the variables I need to connect exactly right now is the data input, is the data output, is the sample input, is the sample output, and is the trigger data. Okay, because the input array, it is controlled by the application inside the microcontroller, not here in my PC running the Cube Monitor. This is not running the microcontroller. This is running in under my PC. Okay, the data input array is processed inside the microcontroller, but the data input variable, it's my link between my computer world, okay, my computer environment, and my microcontroller. And the data output itself the same. The sample output too. Sample output too. So I need to connect data input, data output, sample input, sample output. And it's very interesting to write down some address here. So basically, I need the data input address to retrieve from my Excel sheet the value of my data input. Each sample of each line of my Excel spreadsheet, input spreadsheet, gives me a data input value, float value, and gives me a sample input value. Remember, the column A, it's my sample input, and the column B B, it's my data input. So it's very important to note, to take a note of these numbers. 28, so okay, this is the address, okay, 2,028 and 30, and ending with 30. 28 is the sample input and 30 is the sample output. I'm gonna explain now. Update. Okay, data input is the 30 and sample input is the 28. I'm gonna move direct to this place. Look at that. Write message, write message. So this write message belongs this branch. This branch, I'm gonna split the column information of my Excel file. So look at that. I have here a button to start my accession. I'm gonna generate just a small delay. This gonna look inside the C temp folder input underline file.csv. That file I already showed you a few minutes ago. So I'm gonna take the information from the columns. I'm gonna use a semicolon separator because it's a CSV file and I need a semicolon. So this is something was very important when you are developing your application. So I'm using a CSV file, okay, with a separator semicolon and with a newer line between each different line of my Excel spreadsheet, okay. Just to give you an explanation, I'm gonna show you. If I open my input file here with some tool like Notepad++, which is very useful for that, look at that. My Excel spreadsheet sample in the column A and data in the column B, and the semicolon as our separator. Okay, sample, semicolon, data, sample, semicolon, data, and from each line to line here I have a new line. Okay, so it's very important. So some interesting tool you're gonna need in different projects and to understand. So the Notepad++ is very useful for that, for example. All right, coming back to the Cube monitor, I have here a formattation. So basically in this branch here I get the column sample, I split the column sample and the column data. So to do that, basically I'm gonna get a payload message and I'm gonna get the sample column, okay, and I'm gonna direct to this sample column to this place here, this flow here, and under here in this branch I'm gonna retrieve the payload from the data column. So sample and data. So I have here a filter variable here, okay, to transform this as a number. Okay, my message is basically an ask message, okay, and I need to transform this as a number because I'm manipulating numbers, as you already know. So this is very important now. Write message. So this is the branch for the sample, and which address is actually connected to the sample? Look at that. Let's remember here my variables. Sample input. Look at that. Sample input is actually connected to the address finishing with 28. And data input is connecting to the address finishing with 30. Okay? 28 and 30. 28 and 30. It's very important. Look at that. I'm using a sample frequency of 5000 Hz, 5 kilohertz, which is more than enough for my accession here. So you can basically change these properties here too. So it's very complex tool in order to understand. So 28 is the sample input and 30 is the data input. So I'm gonna move here and I'm gonna change for 28. That's it. And I'm gonna change here for 30 with 30. Look at that. Variable type. Okay, type 9. So you have to find some documentation, and it's very important to know that different values represent different variable types. So the 9 it represents the float type variable. And of course, our data is a float data. So this is why I'm using here a type 9 for a float variable, okay, in the JSON syntax. This one, it's not a float, it's an integer variable. So I'm going to use the type 5, which belongs to the integer variables. Okay, same JSON syntax here. Okay, 28 is the address for this variable, for the sample, and 30 is the address for my data variable. Okay, following the flow, this you're gonna call the set topic to write the information and write this information in the probe output. So look at that. We get the first column, separate the value from the first column, connect to this value to some variable address, some proper variable address in our microcontroller. In this case is the sample input variable address. So you're gonna catch each line from my CSV file. Each line from my CSV file, I'm gonna take this information, I'm gonna split between the two columns. The first column, I will get its value and save its value in the sample input variable. The second column, I will separate its value, okay, treat its value, and copy its value to the data input variable. After that, I'm gonna connect this by the ST link to the application running the microcontroller. So this is the input, basically, process. The output process is something similar, but look at that. In the output process, I'm gonna connect my variables to a chart, and this chart, of course, it's a chart that you're gonna see. It's a graphic chart, and I'm gonna split in 3 different variables. The first variable is the data output. The second variable is the sample output. And the third variable is the trigger data. As I explained it before, I have 3 columns in my output Excel. So I'm gonna basically copy this information, this payload, and those 3 variables. I'm gonna group those 3 variables in a CSV file. And look at that. Those those flows generated by this tool, by the Cube Monitor. I don't gonna dig here too much in this tool, but you have different possibilities here, okay, different nodes here to explore. So you can connect MQTT, TCP input, TCP output, and so on. Serial. The serial input and output is explained in my Mastering STM32 microcontroller course. So if you look at that, if you double click, this has some subflow templates. So this is actually what we have inside this group variable in a CSV file. It's very interesting, okay? So this basically create our output CSV file with the desired information. Okay, and this generate the CSV file under the temp folder, and it's called logfile.csv. So this is generate logfile.csv in the temp folder. Okay, other very important feature from the Cube Monitor, okay, is this debug node. The debug node is very useful when you are creating your application. Look at that. Those are comment. They are not using. This is used, okay? But if you wanna comment this, also you can comment this node here by coming here in the flows, okay? And basically just, for example, this one is here, and I can disable this, or enable, or disable. So it's very useful when you are programming to have this debugging message. This will create basically here under the debug tab here some message. So you can basically check variables, check important information. So I use those information in the node programming here to understand the behavior of my application. So that's it. Now I need to deploy my application, and I'm gonna call the dashboard. So the dashboard, it's here itself, as you can see. And in my dashboard, I have here the buttons start and stop acquisition. And my three variables, as I already mentioned before, which is connected to the chart, my three variables, which is basically data output, sample output, trigger data, and my two input variables, which is connected here, it's the data input and sample input, my five variables, they are connected to the chart. So I can explore and understand the behavior of my application created in the Cube IDE. Okay, let's come back to our application, the application itself, which is recorded, installed, transferred to the microcontroller, and understand the behavior. If you check it out, the first state, in the first state, the application itself, you will look for each sample input different from the sample old value. So each input value, if each different input value, 1, 2, 3, 4, 5, from the sample old value will actually go inside this if statement. We'll save the data input value to the data input array. Remember, the Cube monitor, we are reading from the first column of our Excel spreadsheet the sample input, and we are connecting this value to the sample input variable. So each different line from my Excel, from my input Excel spreadsheet has a different number, 1, 2, 3, 4 in a sequence. Okay, so each different line has a different sample number. So each sample number will trigger inside this if statement, and we'll copy the data input, which is connected actually in the column B of my spreadsheet, and this will be connected to the data input variable, and this data input variable here in this line will be connected to the data input array in its proper position. Okay, making this every single sample, we're gonna basically increment the sample input step by step and save the correct, the sequence data, the sequence input data from my spreadsheet to the data input array. So this is the first thing. So when we reach 1026 samples, this moves automatically to the state number 1. The state number 1 will make basically a copy from the data input array to the data output array. So the data output array will receive exactly the same values from the data input array. That's it. Okay, great. So in the next step, we're gonna move to the state number 2. And the state number 2, we're gonna make differently from the state number 1. We're gonna move sample by sample in the data output array, and we're gonna save this value to the data output variable. We're gonna wait some time, create a toggling function in my trigger output variable, and each sample will be saved in the data output respecting this 15 millisecond sampling time, which is more than enough in my Cube Monitor application to generate each sampling line from my output spreadsheet. When I reach 1026 samples, it means that I finished to save everything in my output spreadsheet, and I can skip and move to the state number 3. So this is basically what's gonna happen, what I expect to be happening in my Excel spreadsheet and in my Cube Monitor application. So coming back to the Cube Monitor, coming back here to the, let's deploy again to make sure. Let's call the dashboard and let's start acquisition. And let's check here in the graphic area if it happens the same behavior as I already explained before. So start acquisition, waiting about 3 seconds, and look at that. All right, look at that, it works. So I'm gonna explain later on what's happening, okay, when I finish. The sample input, the first case statement, it reached the maximum, and now look at the data output. and the red is the sample output. So the sample output is 15 by 15 milliseconds, incrementing its value, okay, and saving its data output data to my output spreadsheet, So we are now after 500 samples. We need to reach more than 1024-25 samples. So let's wait till finish it, the process to generate my output spreadsheet. Okay, it's almost at the end. And all right, so it finished. Look at the sample output, moves to 0 and finish the value. I'm gonna stop execution. If you wanna make some movements here, you can click and show all. Look at that. This is very interesting. This is the beginning, the first step of my state machine. So in the first step, we're gonna read the sampling input from my input Excel file, input spreadsheet, line by line from the Excel line or sample by sample, okay, it's the same. This we're gonna connect it, send this information to the sample input and data input variable, and it's gonna be transferred directly to my application, direct to my data input buffer. After we finish the 1025 samples, okay, we're gonna move to the second state. The second state we made basically a copy and paste. We copy the values from the data input array to the data output array. In the third state, we're gonna move step by step. Look at that. This is very interesting. So step by step, each 15 milliseconds, as I already mentioned before, we're gonna take the value from the data output array, connect each sample to the data out variable, which is a float variable. The data output variable will be connected to the specific column of the output spreadsheet and will save its value. And if you remember the first values from my Excel spreadsheet, they are float values and they are 5 values positive and 5 values negative, as I already mentioned before. So this basically here, looking at that, it means that my application and my Cube Monitor application, it's working. So this is fantastic. Okay, so next, let's analyze our output spreadsheet to see if it works, if it really works. All right, as you can see here, the output spreadsheet was generated under the temp folder. So I'm gonna open this file to analyze the values. Okay, only reading for the moment. So as you can see here, the data output, it looks quite strange because I have to change something in my Portuguese Excel. Okay, so as you can see here, those values are not the same as the ones we configured, the ones we generated in the input Excel. In the input Excel, we generated like 10, okay, comma 3689, for example, and here it generates the whole number here. Okay, so in my case, my Excel, I need to come here at options. So this is in Portuguese, I'm sorry, because it's the feature from my software, but in English it looks the same here, the position of those configurations. So here in the advanced, in my case, this was with the separators, the system separators for decimal, milliard. So I need to skip this, to leave this empty, so not use this, unselect this, and click OK. This of course will not change automatically here, so I have to close my Excel, doesn't save here, and open again my spreadsheet. So let's see and hope it works. All right, as you can see here, now I have the correct values, the ones I set on the input spreadsheet. So at the very beginning of the spreadsheet and even at the end of the spreadsheet. So far so good. Now let's work with our spreadsheet. The first column, it was generated automatically by our Cube Monitor application. So in the Cube Monitor application, okay, one of the nodes, it generates automatically the format for our output spreadsheet before saving actually the spreadsheet. And in this, we have automatically some timestamp definition. Okay, so you're gonna basically delete this, exclude this column because we don't need it at this time. So the trigger data 0101, the toggling. So I'm gonna find the information when this column is 1. So as you can see here, we saved 25 milliseconds 0, 25 milliseconds 1. So I'm gonna skip the first 25 millisecond values and I'm gonna use the last 25 millisecond values. So I have sure when I'm using that I have the correct numbers in the sample output. So this is the little trick we implemented. Okay, so I'm gonna make here data filter, so in Portuguese, but in English version the icons are pretty the same. So filter, I'm gonna select 1 instead, and that's it. So I'm gonna choose columns A and B, make a copy, and I'm gonna paste here in another sheet. Alright, so I don't need this anymore, so I can exclude. Perfect. And now you can see we have some repeated values. Okay, so I'm gonna basically, what I'm gonna do is I'm gonna select both columns. I'm gonna move here to data again. I'm gonna remove duplicates and I'm gonna assume the sample output as my duplicate based columns. Okay, sample out. So I'm gonna remove all duplicate values and leave only one value for each row. So instead of having here 6, 7, 1, you have only 1, 2, 3, and so on. So I'm gonna select OK. And as you can see here, it left 1026 values. Okay, the correct number of my samples. Sometimes this value here, it can be smaller than 1020, 1024, but it depends on the recording process in the Cube Monitor feature. So in the Cube Monitor, as you could remember, we use some delay, 25 milliseconds delay to generate the toggling values, okay, and to give some time for the Cube Monitor to save the spreadsheet values. Sometimes they can left some values. This can be important or not. For example, if you are analyzing the filter data that you have several samples to generate input value, this sometimes is not a big deal because you have more than enough samples to analyze the output values, to analyze your output wave, let's call it like that. Okay, but if you want, just generate it again till you reach 1026 values. So in this case, with 1026 values, it means we generated in our output spreadsheet all necessary sample values. Okay, so this is fine. So as I explained before, don't worry if it generates for the first time less values than 1026. Generate the spreadsheet again, okay, that you probably found 1026 left values. So that's okay. In my case, it generates. So now I have here in the column A my output and here the sample value. So I can basically delete this. For example, I can delete the column B and Here in the column A, I have my output values. That's it. They are correct if you remember the input spreadsheet. Okay, so I have here the 4 values positive, 5 values negative, and now the decimal values, okay, the integer values here, that is 10 times my sample. So 10 times 10, 100. 10 times 11, 110, and so on. So this is pretty cool, and it works in the generator. 772, 7720, and so on. So in the last values, as you can see, they are also floating values. They are was generated correctly. So I hope you enjoyed this video, and see you in the next one.